Jim Simpson, Climate Emeritus at 5 Doc. Thanks for coming along this evening. Good to see lots of faces I've seen before and a few new ones. Sad to say that Robert Brown from the Shooters and Fishers Party, MLC, and New South Wales Government couldn't be with us tonight, but John Preston in his stead. Welcome, John.
The house is sitting.
Yeah. The next best thing. Welcome, John. A little bit of housekeeping. Ian will be joining us on the floor in a moment. Question and answer after Ian's had some words to say. My great pleasure to invite IAN PLIMER to come to the front and centre. He's in Sydney. We're fortunate to have him this evening. He's speaking tomorrow at the Friedman Conference together with Joe Nova, where I'll be, tomorrow, on Saturday. Sorry, Saturday. No, today's Thursday. So they're speaking at a Friedman Conference at UTS. Ian, the floor.
Thank you. Well, folks, thanks for coming. There is a magnificent four-letter word that destroys a lot of the arguments that we're facing at present. And that four-letter word is time. And if you look at history, you can destroy all this kerfuffle that we're hearing about Western civilization. Because unless you know history, you cannot argue about where we are in time. Creationists are wanting us to have a planet that's 6,000 years old and there was a great flood 4,000 years ago, and I've been to Mount Ararat. There's no evidence of a flood there. And what destroys the creationists is time. And what destroys another fundamentalist religion, and that is the green religion, is time. If you look back in time, then you can only be anti-scientific to maintain the position that our warmists have. And just a very brief run through time, and then some of the processes that we use to show that it's not that we're sceptical of human-induced global warming. We're very patient people. We've been waiting 3 decades for a shred of evidence. It hasn't come. There was a day, it was a Thursday, 4,567 million years ago when planet Earth formed. And since then, we have had climate change. It has always changed. So if you're going to talk about human-induced climate change, you have to know what changes have happened in the past and whether we are living in extraordinary times. And I hate to disappoint you narcissists, but you're not living in extraordinary times. You're living in really boring times, and the powers of natural processes are far greater than anything in your overinflated ego, anything that you think you can do. So we are not living in unusual times. And what we've had for more than 80% of time is the planet has been warmer and wetter than now. We're actually living in a time where we've got an unusual rock on planet Earth. It's called ice. We've had ice on the Earth for less than 20% of time, and it is that ice that is the key to climate change. But we don't hear much about that. We've had 6 huge ice ages. The first one we know very little about, and that is called the Pongolian. We see evidence for it in South Africa. It formed about 2,900 million years ago. But we can see the evidence that there was ice, and that is the debris that the ice has left behind as it's retreated, because as ice advances, it picks up rocks and soil and fingernails and paddle pop sticks and everything. And then when it retreats, it leaves all that behind. And we only see evidence of that glaciation in South Africa. We don't know whether it was a global glaciation, a global ice age or not. But the next one is the Huronian, and that's a really interesting ice age because that occurred some 2,500 million years ago. And we had the planet covered in ice. We had the poles covered in ice. We had the equator covered in ice. A very unusual event, and I'll come back to that. And that ice gives us some fundamental scientific questions. How did we cover the planet with ice? And how did we lose all that ice? That was a huge climate change. And the really simple answers to those two questions are, we don't know. And if you don't know how the biggest climate change on Earth occurred, then the very slight aberrations we're getting today pale into insignificance. But what we do know, it's written in stone, is that just after that ice started to retreat, and the finely ground up pieces of rock flour ground to a very fine grain size, the meltwaters washed that into the oceans. And all of a sudden the bacteria in the oceans, which were anaerobic bacteria, very primitive bacteria, all of a sudden they said, wow, I'm going to have a bit of this. And they then got fertilised with all this food, and they diversified from one group of bacteria, which had just a cell wall and no nucleus, and another group of bacteria that had a cell wall and a nucleus. And that nucleus prevented the bacteria dying from a poisonous gas. And in fact, that bacteria pumped out a poisonous gas. And that poisonous gas was called oxygen. And we started to have bacteria in the oceans pump oxygen into the atmosphere. The bacteria that didn't have their protective nucleus, we went through this period of natural genocide. Not all of them died out. You've still got some of them inside your gut. We've still got them in swamps and bogs. But we had a natural period of genocide and a diversification of life because of climate change. And we started to have enough oxygen in the atmosphere where it started to dissolve in the oceans. And there was one day when the oceans actually precipitated iron oxides. That one day the oceans rusted and we formed the great iron ore deposits of, say, the Pilbara. So what that tells us is that what happens in the atmosphere and what happens with climate and what happens with life and what happens with the rocks, they are all interlinked. And the message we're getting today is it's only the atmosphere that drives the climate and drives the planet. It's nothing else. That is absolutely and demonstrably wrong. And if you start using that four-letter word, which gives you a much more thrilling life history, then you can see it's wrong. And that process happened again. We went back into our normal boring times, and we had the boring billion in the geological record where it was boring, and a lot of that boring billion material is in Australia, still flat lying, hasn't been twisted, hasn't been cooked up, it's still there, just look in the Northern Territory. And then we had an extraordinary time where we had yet again a period of snowball Earth, where we had the poles covered in ice and the equator covered in ice. And I quite often take school groups out to Arkaroola, and we get them thinking of fantastic ideas, the Alice in Wonderland trick, you know, how many fantastic ideas can you have? Well, in this case, before lunch. And I get them to work out, and these are 16-year-old kids, I get them to work out that at Arkaroola, some 700 million years ago, we had an ice sheet that was 20 kilometres thick, covering that patch of ground. And then I get them to work out that that ice sheet was at the equator. And we then get them to work out that it was at sea level. So what an extraordinary situation, 20 kilometres of ice at sea level at the equator. Again, the fundamental questions, how did it happen? How did we get all that ice? And how do we come out of that global gripping ice age? And again, the same answers. We've got a lot of good ideas, a lot of theories, but we really don't know. And we came out of that great ice age, the Sturtian, and we can see that above the debris left behind the ice, there is a limey horizon. And that limey horizon is actually got some chemical fingerprints in it where you can work out water temperature. that ice probably formed at -40, and we can work out from that limey horizon that the oceans were only plus 40 degrees Celsius. There's nowhere in the world today where the oceans are that temperature. And with such warm oceans, that really did stimulate the bacterial life. At the same time, all the nutrients getting washed out of the ice sheets, and the bacteria in the ocean say, beauty, I'm going to have some of this. And they diversified, and they diversified into complex multicellular life. We see a couple of reefs in the far north Flinders Ranges at Balkanuna and at Arkarula. It's called the Arkarula Reef, where we've got coral-like structures, multicellular. Then we go back in time and have a look, and we see that we've got reefs all through time. Before that, the reefs were bacterial, rather like some of the reefs we get, say, in Western Australia at present. They were bacterial. And all of a sudden, we got multicellular organisms there. But we've got a 3,500 million year record of reefs. Reefs come and go. We can see evidence in reefs of critters coming in and attacking them. We see evidence of reefs dying out with great frequency. Our Great Barrier Reef is no different from previous reefs on planet Earth. So we had this Arkarula Reef thriving with multicellular life. And what happened? We came into another glacial event, the Maranoan. What happens when you get cold climates? Reefs die, and we see it. That reef got wiped out, and another big glacial event again. Ice at sea level at the equator, and as the ice retreated, we washed nutrients into the oceans, and again we saw multicellular life appear, and that was the Ediacaran fauna. So the first three great ice ages, two of them were at the equator and at sea level, and drove diversification of life. And then we get into the time when we had an explosion of life. And there was a very good reason why we had an explosion of life. We'd put enough nutrients into the ocean where critters could really thrive. They could suck up these nutrients, they could diversify, and they could use some of the nutrients from the oceans to make shells. And that started to draw down carbon dioxide from the atmosphere. And we can do some calculations to show how much carbon dioxide was in the atmosphere. When we had these big glaciations some 600, 700 million years ago, we formed a rock called dolomite. Now that rock you might use in your garden. Dolomite is a calcium magnesium carbonate, and we can make it. And we can make it from seawater if that seawater has a huge amount of carbon dioxide dissolved in it. So if it has a smaller amount of carbon dioxide, we get limestone, and if it's even got less carbon dioxide, we get gypsum. So we can measure the sequences of dolomite. There are sequences of dolomite 20 kilometres thick in many parts of the world, including the McDonald Ranges and the Flinders Ranges and the Barrier Ranges, where you can say, okay, we've got this 20 kilometre thick sequence of dolomite. Dolomite's got 49% carbon dioxide in it. That's where the carbon dioxide went. We once had an atmosphere, if we put that back into the atmosphere, of about 20% carbon dioxide. Currently we have 0.04%. So when we had 20% carbon dioxide, what did we have? We had ice ages. We didn't have runaway global warming. So the answer's written in stone. If you look back in time, you can see that carbon dioxide has not in the past driven climate changes, and it was percent carbon dioxide in the atmosphere. Now it's 0.04%. So what time shows us is that a high atmospheric carbon dioxide content does not drive global warming. We still have massive climate changes. And then we continue to go through history. We've had a few more glaciations. We see one glacial event where we see little bits of it in parts of Europe and the US. We don't see much of it here. We had another glacial event, which you see here. You see in Wollongong, Newcastle, Lithgow, and this is when we were part of a supercontinent over the South Pole, and we were covered in ice. And that ice retreated and expanded many times. And our coal seams that occur in the Sydney Basin, you think of coal forming from Amazonian type swamps, but it doesn't. It forms from cold climate peat. It forms in cold climate conditions, and it's commensurate with all the ice that we see that was in this area. And then we had another ice age. We see evidence of that in the opal fields, where you have opal dirt and a huge big boulder sitting in that opal dirt. Couldn't have been washed in there, because we would have washed the clay away in the opal dirt. And that formed by ice that had been grinding across the surface, broke off, floated out in the ocean, melted and dropped that boulder into marine sediments. So we see 6 major global ice ages in the geological record. We see 4 of them very well preserved in Australia, 1 not so well preserved, and the first one we don't see here. So if you are going to start to argue about climate change, you have to say, what has the climate done naturally, and how are the changes we see today, are they static in the line, or are they major changes that just suddenly appeared? But the more modern record is even better. We are living in an ice age. Why? Because we have polar ice. And that ice age has been going for only 34 million years. And as soon as we started to get polar ice, we had big changes to life on Earth. That polar ice probably arose from South America and Antarctica being joined, and South America pulled away and moved northwards, and we had this big circumpolar current develop around Antarctica, stopping warm water getting in there, so it froze. And that ice sheet over the last 34 million years has been expanding and it's been contracting. It's been expanding and it's contracting. And what has driven that? Well, it's been expanding and contracting because of a number of changes, and no matter what legislation Canberra enacts as a result of Paris, it's not going to change the Earth's orbit. The Earth's orbit varies from elliptical to circular every 100,000 years. So we get further away from the sun and closer to the sun. The Earth's orbit varies every 43,000 years, where we get a little bit of a change in the orbit due to the axis changing, and we get closer or further from the sun. And we get a wobble, a bit like a wobble in a top, and that's every 21,000 years. So we get closer or further from the sun. So once we start this great period of refrigeration, the slight orbital perturbations put us closer or further from the sun, and that means that the ice sheets expand and contract. And for a long time, people have spoken about a solar constant, how the sun puts out a constant amount of energy. It doesn't. It varies enormously, and it's cyclical, and it's also accidental. And so we get cycles every 1,500 years, 217 years, 87 years, and 22 years. And those cycles might not change the amount of light coming out of the sun, but it changes the amount of energy coming out of the sun. And we see those. This has been known for a long time, the sunspots, which are dark spots on the sun where we're getting great fields come to the surface of the sun, and that affects the Earth's magnetic field. When we've got a lot of sunspots, the Earth's magnetic field is way beyond Jupiter. When we have fewer magnetic spots on the sun, or even none as we've currently got, the magnetic field comes right in. Now what that means is that that magnetic field is not protecting us from cosmic radiation. And every time you get a supernova eruption, you bombard the planet with cosmic rays, and we've shown it experimentally, we've shown it observationally, and we've deduced it from chemicals, fingerprints that form in the cosmos. And so we're pretty certain that cosmic radiation changes the amount of cloud cover. The more cloud cover you have, the cooler it is. So we've got a variable sun, and we've got variable tides. We've got lunar nodal tides every 18.5 years. So once you start a big cooling trend, once you may be sitting at a pole, then all these other little factors have an influence. And what has been happening in the last 34 million years is we've been cooling and cooling and cooling. But it's been in a cycle of expanding and contracting ice. And in one of the warm periods, that was 18 million years ago, Melbourne was tropical. Now, I was there last week, and God knows you need it. It was tropical. And much of inland Australia was tropical. And you can see remnants of this tropical vegetation right out back. You can see it in some of the gorges and canyons like Kings Canyon. You can see it at a place called Hidden Valley up in the Strzelecki. This is tropical vegetation from that period of time, and it's been hanging on by its fingernails, and it's still there. And so we see these great changes. And then about 7 million years ago, we started to come into a fairly rapid period of cooling. And you hominids, which first appeared 34 million years ago, you had a choice. The choices were simple. You could stay as you were, and that's guaranteed extinction, or you could do something really smart. You could actually walk from one copse of trees to the next. And we know that because the fossil record shows footprints. And we've got fossils where the hip structure shows that hominids could walk. That was climate driven. And every time it got cooler, we wiped out some of the hominids. And the carnivores will be pleased to hear that every time it got cool and we got an extinction of one branch of hominids, those that died out were the vegans. They went. And so I'm a great supporter of vegans. I'm a great supporter of vegetarianism because I eat vegetarians, but they died out. So there is some good news. But we had an extraordinary period of time 2.5 million years ago. And again, we had sudden cooling. And it wasn't driven by the sun. It was driven by a supernoval eruption. We can still see it. That blasted the planet with cosmic rays, had a lot of clouds formed. It suddenly cooled down. And those cosmic fingerprints we can find in mud, silts and sands all around the place. And at the same time, coincidentally, unrelated, was South America joined to North America when the volcanoes spewed out a lot of lava and glued the two continents together, and that stopped ocean water transferring from the Pacific to the Atlantic. Now, it's not the atmosphere that holds heat, it's actually water. Water has a very high heat capacity. Try it out. Go into the bathroom and run a hot bath, and the air warms. Go into the bathroom and point a radiator at the water and see if that warms up. It doesn't. So water has a very high heat capacity, and the surface temperature of the Earth is not driven by the atmosphere, it's driven by the oceans. Water is the key to climate change. You heard a talk on that, what was it, last week, was it?
2 weeks ago.
2 weeks ago. So water actually is a key element, and we never hear about it. But when we closed up at Panama, it meant that we couldn't transfer heat. And we had a lot of clouds, and we rapidly cooled down. And you appeared. Your species, Homo, appeared. Now, you were shorter, you were a dwarf throne candidate, but you had a brain that could function better than your predecessors. And in your brain, you had a Broca's area, which is the area for communication, and we know from the larynx structure of the fossils that they could talk. Now, they might well have had a limited vocabulary, maybe that of a rugby league footballer, but they could still talk. And you need vocabulary if you're going to hunt. You need to be able to communicate with your other hunters. And we know that they were very efficient hunters because we see fossils of older people that have had broken bones, and those bones have healed, and these people must have been fed. So there must have been excess food. If there's not enough food, then the hunters eat it, and the old codgers die off. So that was when you appeared, Homo, and you appeared because of climate change. Climate change has actually driven the evolution of humans. And we continued to have these fluctuations of cold and warm and cold and warm. And we go to the last ultra-warm period. And in an ice age, you have glaciation, that's when the ice sheets expand, and an interglacial, when the ice sheets contract. And the last big interglacial was between 116,000 and 128,000 years ago. And there are 4 of you hominids on planet Earth. Homo sapiens, and I've always worried about the sapiens bit. Homo neanderthalensis, they had bigger brains than you, than Neanderthals. We had the hobbits in Indonesia, and we had Homo erectus, upright human. And they thrived in those warm times. What happened in those warm times is the forests took off, and the amount of forestation on this planet was much, much higher than before. By the way, we had higher carbon dioxide content than now, but correct me if I'm wrong, but I don't know of any factories or motor cars belching out carbon dioxide 125,000 years ago. And it all started to come pear-shaped about 116,000 years ago, when we started to get a bit further away from the sun, and we started to cool down. And we're in an ice age, we started to cool down, the ice sheets expanded. Then what happened is you humans started to pop off. And 3 species became extinct, and you, Homo sapiens, very nearly dropped off the perch. And it happened with a dirty big supervolcano in Indonesia, Toba. Now, most big volcanoes bang out about 30 cubic kilometres of dust into the atmosphere. It's called ash, but it isn't ash because nothing's burnt. There's fine needles of glass. And you breathe this stuff in, your lungs bleed, and you fill your lungs with blood, and you keep breathing this stuff in, and that is pozzolan cement. That's the cement that the Romans invented, and your lungs actually become lithified. It's better to be hit with a big boulder in an eruption. I've got an article about this in next week's Spectator, by the way. It's better to be hit with a dirty big boulder than it is to breathe in volcanic ash. Just go quickly. And Toba, being an equatorial volcano, put out dust into both hemispheres. Now, a normal big volcano like Krakatoa in 1883 puts out 30 cubic kilometres into the atmosphere. Toba put out 3,000 cubic kilometres into the atmosphere. It was a supervolcano. There are other supervolcanoes, those at Yellowstone and Taupo. Now, in Taupo in New Zealand, they banged out about 10,000 cubic kilometres of dust into the atmosphere, and we pray for it again because I think that's the only way we'll ever win the Bledisloe Cup. And in Yellowstone, some of those have put out 100,000 cubic kilometres of dust into the atmosphere. I've just come back from Ecuador, and I'm going back there next week. There are 34 volcanoes around the capital, Quito. You can see volcanic ash layers upon ash layers upon ash layers. There's no soil that's formed on those ash layers. They haven't had time before another one drops there. If you get one of these big explosive volcanoes in Ecuador, shouldn't say equatorial Ecuador because it is, and they have a lovely beer called Zero Latitude Beer. Highly recommended. Because the equator goes through the northern suburbs of Quito. If we have another one of those, a big volcano at the equator, we will have a period of volcanically driven cooling. So it's happened before, it'll happen again, and you're not living in an unusual time. So what Toba did was it put the human population under so much stress. We lost all of the tropical vegetation. Humans went northwards and southwards. That was 74,000 years ago. That's when we got the first ingress of people into Australia. They left tropical lands to come to a land that was a desert. And deserts don't form in hot conditions, deserts form in dry, cold conditions. Again, completely misunderstood. And we had people come to Australia. We probably got down to about 7,000 people in the gene pool. We very nearly became extinct. Very, very nearly from one volcano. And one volcano can ruin your whole day. And I need to lubricate after that little bit of wisdom. And we kept cooling and cooling and cooling, and we were at the zenith of the last glaciation about 20,000 years ago. And it was cold. It was a good 15 to 20 degrees colder than now. And populations were hunters and gatherers. A lot of the country was covered, or a lot of the planet was covered with ice. We had ice down to about 38 degrees in the northern hemisphere. We had 5 kilometres of ice on top of Scandinavia. That weight of ice pushed Scandinavia down. The ice is now gone. Scandinavia is rising. So if any clown ever starts talking about sea level rise, ask them a simple question. What's the land level doing? Is the land rising or falling? Go out here and have a look at Sydney Harbour. That's a drowned river valley. One of two things has happened. Either sea level has risen or the land level's fallen. Go along the beaches and you see the rock platforms. And those rock platforms are where the land's just risen a little bit or the sea level's dropped a little bit. Those rock platforms are about 6,000 years old. We'll come to that in a second. So we cannot talk about sea level change unless we talk about land level change. And you say, oh yeah, that's just geology, you know, things happen really slowly. Total bullshit. Go to the port of Ephesus in Turkey. Again, the major Turkish brand of beer is Ephes. Go to Ephesus. Mentioned in the Bible, it was Mary's town. It was a port. It's 15 kilometres inland and 17 metres above sea level. So what's happened? The land has risen. Go to where coins were first minted in Lydia. I've been there. Been down the main street in a yacht because the land has sunk. So the land is going up and down all the time. You see it here all through Eastern Australia. It's happening in Eastern Australia still because we had the extremely good fortune 100 million years ago to push New Zealand out into the Pacific and give them their well-deserved earthquakes and volcanoes. And Western New Zealand is lifting up like that, and Eastern Australia is lifting up like that. We've got the same in Western Australia. The Darling Range is lifting up like that, and the Drakensberg in South Africa is lifting up like that. It's a normal event of rifting. So you cannot, as a coastal local government, take measures against sea level change or rise unless you know what the land level's doing. Brisbane Airport is built on marine sediments that are a couple of metres above sea level. So sea level must have dropped or the land level must have risen. In the case of Brisbane, that sea level, old sea level there, is about 6,000 years old. So 20,000 years ago, we were in the peak or the zenith of the last ice age. We started to get the first little whispers that things were going to change about 12,000 years ago. We started to have rapid temperature rises, ice sheets started to melt, and immediately you hominids, it's probably related to climate, but we're not sure, started to get much smarter. And you started to live in villages. Things must have been tough because you had to fortify your village. And you also gathered together dumb animals that herded. And so you had sheep, goats and cattle, which you could herd. You also collected grasses, which you ate. And some of these grasses you could make into bread, you could make into beer, which has been around for 10,000 years or so. And all of a sudden we got smart. We've only been eating grass or wheat or grain protein for about 10,000 years. And some of you have adjusted to it, the celiacs haven't. It takes time in the evolutionary table to adjust to these great changes. So about 11,000 years ago, something extraordinary happened. Big dams of meltwater just burst into the oceans. Sea level suddenly rose. And the top layer of sea level was very cold, fresh water, and beneath that was warmer, denser saline water. And we suddenly had a flip in the temperatures. And we had about a 14 degrees Celsius change that took place in about a decade. And that period, the Younger Dryas, really did wipe people out. If you want to die from climate change, don't worry about it warming. It's the cooling that kills you. And then we had, at the end of the Younger Dryas, it warmed up again. The Younger Dryas went for about 1,100 years, then it warmed up again. And that was an event of global warming at about 15 degrees Celsius in a decade. That was global warming. And what happened to we hominids? We didn't die, we thrived, we took off. And 6,000 years ago, we were at the peak of the current interglacial that we're in. 6,000 years ago, sea level was a few metres higher than now. 6,000 years ago, it was warmer and wetter than now. 6,000 years ago, much of the desert of Australia were grasslands. There was some tropical vegetation there. 6,000 years ago, we humans took off and our population increased, which always happens when it's warmer. And we had fluctuating warm and cold, driven by the sun. In Minoan times, it was warm. And the Minoans had the unfortunate situation of having Santorini erupt. And that was about 1500 BC. The Minoan population, based in Egypt and the Greek islands, was the dominant culture. And if Santorini hadn't exploded and wiped out the Minoans and left space for the Mycenaeans and then later the ancient Greeks to take over, we wouldn't have had Western civilization. One volcano changed the whole course of Western civilization. One volcano can change climate, but let's forget them. You know, we can't legislate about volcanoes, so let's forget about that. And we came into Greek and Roman times. It was warmer. And we know it was warmer from the clothing that they wore. We know it was warmer from the records they've got of crop and salt harvests. It was a wonderful time. And what happens in warm times? People populate, people migrate, economies grow strong, which they did. And then we came into the Dark Ages at about 500 AD. And that was a horrible period to be alive. We had 3 supervolcanoes explode, plus we had a sun that was a bit lazy, and we suddenly dropped into a very cold period of time. The atmosphere was full of dust. People suffered from disease. There was not enough food. There was famine. There was starvation. The weakened population got hit by the plague, which is what we saw in Constantinople. And that was a horrible period to be alive. And then we came into warming, about 900 AD. The first to feel it were the Vikings. And the Vikings, we know, in that medieval warming period from 900 to 1300 AD, they grew barley and wheat in Greenland. They had cattle and sheep. They could dig 6-foot graves because we can see the bodies here. We can date the age of the body. So it was warmer. The Vikings went across to Canada. They called Newfoundland Vinland because they grew grapes in Vinland. Now, you couldn't do that now, and I've drunk Canadian wine and it's horrible. So we know that that period of time was much warmer. But we also know from Roman records that it was warmer too because the Romans grew grapes in Yorkshire, something you couldn't do today. So we've had these great periods of warming and cooling, yet we had no industry on Earth. And the only way that the warmists have attempted to change that is to change history. Hockey stick is a very good example. Change history. Now that to me is a cardinal sin, changing evidence or changing history. More of that in a minute. And that was a glorious period to be alive. We had 2 harvests a year in Europe. We had so much excess wealth that we built the great monasteries, the great universities, the great cathedrals. The money had to go somewhere. And then it took 23 years, driven by a very slight change in the sun, 23 years to go from the medieval warming into the Little Ice Age. And that started about 1300. And we know 1303, 1304, 1306 that the Gulf of Bothnia between Finland and Sweden was frozen. We know that the Vikings had great trouble in travelling to go fishing. They couldn't get across to Canada. We know that there were occasional Viking kayaks seen off Scotland. These people were under great stress and they died out. If you want to die from climate change, it's going to be the cold that does it. And Jack Frost will kill you. It won't be warming because history tells us that and geology tells us that. And in the medieval in the Little Ice Age, the people were so stressed that they succumbed to the plague. The plague is still with us now. I mean, we had outbreaks of the plague here in Sydney in about 1924. I think they were the last ones. But the plague is still on planet Earth. People still get it. But when you're really stressed, you pick up some sort of pox. And in 1347 and onwards, we had the plague. And the plague wiped out a huge number of people in Europe. The population in 1347 got hit hard by the plague. It took 250 years to recover to get back to the 1347 level. During that period of cooling in the Little Ice Age, it got very cold and then a little bit warmer, and very cold and a little bit warmer. We had massive torrential rain, soils were lost, crops were lost, so cold that we could have the ice fairs on the Thames, so cold that the Dutch masters could paint these great hoarfrosts. And there's one scholar, and she looked at paintings and looked at landscapes and looked at how much cloud was there. And she argued that there was more cloud in the Little Ice Age than now. Well, I'm not surprised. That's commensurate with it being cool. And it was cold. It was bitterly cold. And this is when people got frightened of the cold. Again, every time it gets cold, people die. This is when, again, we had starvation. We had the plague. We had a decrease in the longevity. To live to 40 years or so in those times, you were an old person. Looking around this room, you're super old. And what has happened is, since about 1850, we came out of the Little Ice Age. We had a period of warming, then a period of cooling, then a period of warming, then a period of cooling, then a period of warming, and after that, there's been no temperature change. That is the pause. So if you are going to argue that human emissions of carbon dioxide drive climate change, you have to explain all the climate changes in geology, all the climate changes in history, and all the climate changes since we've been measuring temperature. We've had 3 warming events and 3 cooling events. And the one fundamental question that's never been answered is, can you please show me that human emissions of carbon dioxide drive global warming? Drive is the correct word to use. It participates and helps a little bit. Water vapour and carbon dioxide help a little bit, but they don't drive climate change. No one has ever answered that fundamental question. So here we are now. We've got the fundamental question where there is no answer, yet we are reducing emissions of carbon dioxide. Why? Carbon dioxide is plant food. When I first went to school here at Normanhurst Boys High School, the very first thing we learned in physics was measurement. And you measure something, and we got, well, in those days you didn't have 40 kids in a class, so 20 kids get 20 different answers. And that was a really valuable exercise because it told us that measurement has an order of accuracy. You might measure a metre, but it won't be exactly a metre. There's no such thing as exactly a metre. And that is the first thing you learn in physics. In biology, which I didn't do, but the first thing people used to learn in biology was about photosynthesis, where carbon dioxide was plant food. What they learn now, it's not called biology, I think it's called environmental science, is that carbon dioxide is a pollutant. It's toxic and it kills you. And what I've seen in a 40-year history of teaching at, I think, 8 different universities around the world, is there has been a massive decline in our educational standards. Kids are not able to critically think or think analytically. I had kids come into university and they knew all the answers about global warming. They knew the answer before you asked the question. And so there were some really, really simple questions I used to ask them. I say, well, they'd talk about carbon pollution. I say, well, carbon's black. There's carbon pollution. I couldn't see you, could I? Oh, no, it's carbon dioxide. Oh, carbon dioxide. Well, let's just make sure we're talking about the same thing. What is the molecular weight of carbon dioxide? Bang, they couldn't answer it. Well, it's 44, by the way, but they couldn't answer it. And so straight away, you see that these kids have got no background in fundamental science, yet have got a very, very strong environmental opinion. So here we have a situation in a wealthy country like Australia where I'm not at all surprised that our education standards have almost reached those of Kazakhstan, and they're going north and we're going south. And I'm not surprised that the schools are wonderful grounds for propaganda. And at schools at my age that I went to, we used to get abused, and it was fabulous. Because the only way I could learn Latin was with the cane. And the cane hurt more than learning the Latin. So you learnt the Latin. And I thought that was a great teaching method for Latin. And this Latin teacher, he could hurt you. But I reckon he had the right idea. He would cane you unless you learnt your Latin. In science, it was smells and bangs. That's how I got interested in chemistry, because you could make bombs and you get access to the chemicals to make bombs and smells and explosions, and the number of letterboxes used to take out on Manavale Road. It was a fabulous place where you could drop a bomb down one of the sewage hatches and you could see going right up the road all these cast iron sewage things blowing up. It was fabulous, absolutely fabulous. And this is what got me interested in science. It was hands-on. Now kids can't do that now. They're not allowed to touch anything. And I think I had a really good education because it was hands-on and there were rules, and if you broke them it hurt. Now, I know you'll be shocked to hear, but I also got caned for being a smart-ass. And yes, here it is here. I'm still suffering terribly from that. So the education system today, I'm not advocating we bring back the cane or anything, but the education system today does not have a disciplined learning. And I've had kids come into university who cannot write, who cannot spell, who cannot put a sentence together, who don't know basic chemistry and mathematics. And these are people coming into Melbourne University then, and I know we've got a Sydney University chap here, but then and now it's still is the greatest university in this country. And we had kids who could not handle the basics, yet they understood everything about the environment. So these have been easy picking grounds, and the picking grounds are those of envy, those of left-wing politics, those of propaganda, and we are paying the price. Now the price is that we have got something like 2% of our electricity is from alleged renewable sources. Now what that's done is it's disrupted the system so much that this country is in a serious position. We have tens of thousands of years of uranium in our rocks. We're the only G20 country without a nuclear reactor, and I'm not dealing with Lucas Heights, it's a research reactor, it's only 20 megawatts. But we are the only G20 country without nuclear power. We have thousands of years of coal, and there is a massive anti-coal movement. Apparently it's okay to export coal and allow Southeast Asian countries to build their coal-fired power stations and grow to our level, to be middle class, but apparently it's bad for us to do it. It's going to ruin the planet if we use it, but not if they use it. We have a huge amount of gas, and we have a couple of states where gas is off the agenda. In Victoria, which produces a huge amount of gas offshore, you are not allowed to drill for gas onshore. You can drill a hole onshore and have it then go out offshore. That's okay. But you can't drill for gas onshore and collect the gas onshore. There is a major smelter, Portland, an aluminium smelter, that is in serious trouble because of the cost of their energy. When the big power stations in Yallourn were built, they did the deal, and that is we will take this amount of power 24/7, and so the power station could get a bankable study done on that and get finance for it, and Portland could get finance for building a smelter because they had a long-term secure supply of electricity. Those contracts are coming to an end. And what is happening is that by putting a small amount of solar and wind into the grid, we have made it unstable, unreliable, and of course that horrible word subsidy, we now have subsidised power, and that has pushed up the price of power to the point where people are being crippled by it. Employers are sacking people. Businesses are moving out of the country. God help you if you're on a pension and trying to stay warm in, say, cold Melbourne, because the gas supply is insecure, electricity is horrendously expensive. You can't take 1,600 megawatts off the grid and expect nothing to happen. We in South Australia, and I'm only a visitor to South Australia, we're pure. I mean, we have all this wind power, and just in case the wind doesn't blow, we have that fella whose name's like a deodorant. We have some of his. I can't say the name; it makes me ill. We have some of these batteries. It's going to save us. We're going to have electricity for 4.5 minutes, and because we're so concerned about putting this carbon dioxide into the atmosphere as a backup, we have 100 megawatts of diesel generators, and that's only using 30,000 litres of diesel an hour to keep us afloat. Oh, and by the way, if all fails, we've still got electricity because it comes from Queensland, through New South Wales, through the Victoria, across the interconnectors into South Australia, and Bob's your uncle. We are green and wonderful, and look at us. Now, that is absolute stupidity. This country was built on cheap energy, and all of a sudden, it's become expensive. And it's so easy to fix. There are contractual arrangements between energy companies and the government in terms of subsidies. But there's an easy way around that. The easy way around it is through regulation. And the regulation you would put in is saying, well, if you're generating electricity, you must produce electricity for 90% of the time, 24/7, 365 days a year. And then all of a sudden, bang, you've lost all the sponges, because these wind complexes, I don't call them farms because farms actually produce something useful. These wind complexes do not harvest the wind, they harvest subsidies. And that subsidy goes onto your electricity bill. How can you, as an environmentalist, argue that this blight across the hilltops is environmentally good? How can you, as an environmentalist, argue that slicing and dicing birds and bats is good for the environment? You can't. Why have we got them? It's a mechanism of exerting power by the unelected over you. And I think we are in a major battle in Western civilisation with who has the power. Are they our elected representatives? And, you know, they're pretty pathetic anyway. I mean, do we have any leadership in this country? Are they our elected representatives, or are they people from the NGOs, from the power companies? Are those people those that control the agenda? And in my view, we have made some tragic errors in this country. I don't have a problem with wind and solar if it's not subsidised. In the outback stations, outback signals for trains, outback phones, they're solar, and for a very good reason. A lot of stations have a little wind generator, 32-volt generator. Fine, absolutely perfect. But why should we all subsidise it and then, as a result, pay higher electricity prices and put people out of work and have people living in cold houses? I stayed Thursday night at a friend's place in Hepburn Springs in Victoria. He's a pensioner. He's closed off most of his house in winter because he can't afford to heat his house. Now that's just bloody wrong. That should not happen in a wealthy country like Australia where we have an excess of energy. And I believe what's happened is that we've had a deconstruction for a long time, for maybe 40 or 50 years, with attacks on every institution in this society and taking control of every institution. I'm talking about, for example, education. And we are now at the point where we are in serious trouble, I believe, in this country. I do not think our current government can change it. I do not believe an opposition can change it. I think it's got to get far worse. I think we've got to create massive unemployment. We've got to have pensioners die, they don't count, but if we have people die on the operating table and screaming babies and crying mothers and angry fathers, that's going to change it. Now, we had a situation in South Australia sometime this year where the lights went out in the Royal Adelaide Hospital. There were people with their gizzards open being operated on and there was no power. Now, that's got to happen many, many more times, and then we will get a political change. Because the only good politician is a frightened politician, and your vote is worth the same as someone else's vote, and our job is to take back control of this country's destiny. Because if we don't, our kids and grandkids looking the age here, if we don't, this country will go the same path as Argentina did and as Venezuela has just done. And I think we have to take back the reins and take control, because we have been screwed. We've been screwed mainly through the education system. A lot of politicians are of our view, but unity and caucus, etc., forces them to actually sing from the hymn sheet. And thank God we've got a few politicians, Tony Abbott being one of them, Corey Bernardi another, who actually are independent enough to be able to say, this is wrong. So I think we are at the crossroads of Western civilisation. I think we're at the crossroads in this country, and we have a chance of totally stuffing this country, and I think it's time to mount the barricades. So, thank you.
Your description of future policies coincides in fact with some words that I've been developing and drafting. It just happened by accident. You had them with me. So I'm going to leave a copy with you.
Thank you.
It's very short, it's brief, but I think you'll relate well to it.
Thank you.
If you care to critique it, I'd be delighted if you would. Do we have any questions for Ian from the floor? Yeah. Phil. Ian.
Now, here comes a Dorothy Dixon. Come on.
No, just about the first 3/4 of your lecture, and may I congratulate you on the entirety of it, but about the first three quarters of it, you're basically giving a historical description, which, certainly according to yourself, was entirely factual about the evidence, the geological evidence of the fluctuations in the world's temperature up to the present day. Now, our opponents what do they do in relation to those facts? Do they choose to ignore them? Do they agree with them but draw different conclusions from what we draw? Or do they actually disagree with the facts as presented by you? So there's three choices there. What do they do?
Generally ignore them by saying it's just geology. Now, a fundamental of science is evidence. And we come to a scientific conclusion based on observation, measurement and experiment. And if you do that work and come up with a conclusion, it's got to be in accord with previous validated evidence. That's the coherence criterion in science. If it's not in accord with it, you have to abandon your conclusion. You have to abandon your theory. Now, this is exactly what the creationists do. There's a huge body of evidence out there showing that the planet is not 6,000 years old. There's a huge body of evidence out there saying that there has not been a global flood covering this planet 4,000 years ago. They choose to ignore it. And that fits in very well with them being fundamentalist religious people. Exactly the same happens with the warmists. They choose to ignore huge amounts of evidence so that their preconceived conclusion, which they get from computer models, they don't get it from experiment or observation or from measurement, is validated. So I think this is a very serious problem in a Western country where you choose to ignore contrary evidence. You can make a much more elegant and refined theory if you actually integrate that evidence. And I have often compared creationists with our warmists. They are the same. Some of you might know I had an interesting period of my life with litigation with the creationists, and I had 9 cases of defamation against me, and I was really annoyed about that. I wanted to get into double figures. And not one of it got to court, but I cross-litigated on the basis of the Section 52 of the Trades Practices Act and copyright, on the basis that they stole other people's work and that they were misleading and deceptive while engaged in trade and commerce. It was a business, just the same as warmism is a business. Whether you're an academic, winning those research grants, whether you're AGL, it is a business, and it's a great business to be in. So the creationists vilified me. I got death threats. You could not argue. You immediately got shouted down. What's different now? If you say, well, look folks, I think there's some evidence to show that this might not be the case. They immediately attack you as a denier. We hear it in other quarters of society where rather than discuss a matter, they call you a racist. And I just think you have to come in with all guns blazing. You cannot bend your knees and put up with that. You've got to come back at them. And I saw that in that 10 years of litigation I had with the creationists, which was basically a stalemate, litigation-wise. They withdrew all the defos and the other stuff went to court, and it was, you know, a bit of a Clayton's victory. But what I did achieve there is I pushed creationism back into where it belongs, and that's in a telephone box. And my aim was to not have these people come into our schools and teach the kids that the planet was 6,000 years old and there's a great flood 4,000 years ago, and call it creation science, because it wasn't. It was religious fundamentalism. Now, exactly the same's happened with warmism. These people have come into our schools, and they're not the religious fundamentalists, they're the left, and they have given us climate science. And I have found that the best way to argue is to be dumb and ask really simple questions like, well, can you please, you've got to use the word please, can you please show me that human emissions of carbon dioxide drive global warming? And I say, well, there's a lot of scientists that said this. Well, but which scientists? Yeah. How much science do you know to be able to critically evaluate what they're saying? Maybe they're chasing the holy dollar. Maybe it's self-interest. And I know from universities there's not that much money for research. And if you can get it from frightening people witless, that's the best thing of the lot.
The thing is that the scientists have seen the evidence. So, you know, we don't have to look for it ourselves because the scientists have seen it and we trust the scientists.
Yes, I trust used car salesmen and real estate agents also. And if they use that argument, you can say, well, how can you trust the science when you know nothing about science?
Exactly.
And so I've now come to asking questions. That generally gives a violent response. I can count on a sawmiller's hand over the last 10 years how many dinner parties I've been invited to, because I'm an argumentative bastard. I don't put up with bullshit. So basically the debate has been shut down by refusing oxygen. And we can thank God for a few people. I mean, this city, you got Alan Jones, and I'm doing a pre-record with Chris Smith tomorrow. He wants to know what happened here. I couldn't tell him what questions to ask me because I hadn't worked out what I was going to say until I got here. But you have a network here that I think is fairly good. I think Sky's pretty good. The Spectator Australia is pretty good. The Australian gives a moderately balanced view. And I think the ducks are in a row for when things get really worse. I'm praying for an ultra cold winter. I hope it snows in Sydney. That's going to knock off people my age, fine. But all of a sudden, it's going to become a catastrophic political situation.
I think a decent volcanic eruption would remove all that.
Yeah, but
you wouldn't worry about climate change.
The problem with the volcanic eruption is that it's got nothing to do with your actions as a politician. You know, that's, as they say, an act of God. What you need is just an extraordinary cold winter And we may, there are hints there from the sunspot activity and the astronomical information that we're heading for cold times. An extraordinary, what about your old mate there, Philip?
He's still got a bit going.
By the time you go there and back, I'll be finished it.
What beer are you drinking?
Light, oh no, I'm not drinking light now because I don't have to talk anymore. That's just Cascade Light. I don't want any more light. I've finished talking.
Thanks, Peter.
I'm right.
He's in the Q&A.
A couple of more questions from down
The Q&A is always the best because I like them.
Loud voice.
Yeah, you were talking about the Little Ice Age, and you just mentioned that with the solar activity going down, we could be heading that same direction again. There's a historian called Geoffrey Parker who's written a book called Global Crisis. Over about 500 pages, he takes the historical records right around the world and talks about what happened during the Little Ice Age and how dire it was for people and how whole civilizations disappeared. One quote he gave of a Chinese magistrate in China. The magistrates were responsible for handing out the food rations. He said they had people lining up outside his door where people were so hungry that women were eating their babies in the line.
Yeah. There's a book, Peter Fagan's English historian's written a number of books on Dark Ages, Little Ice Age and medieval times. And how dare someone cook the books with the hockey stick to actually kill all this history. Now, exactly that's happening now. What Jennifer Marahasi has shown is that the Bureau of Meteorology is cooking the books. We can't even get a minimum temperature because they don't go lower than -10. Her work on averaging temperature shows that you can get the temperature you want. We have exactly the same with measurement of carbon dioxide. And then this rubbish that you hear about, oh, this is the hottest summer ever. When did you start measurement? What was the order of accuracy? The first thing I did in physics at Norman Hurst Boys High School, what was the order of accuracy? 19th and early 20th century thermometers gave you, say, 15 degrees Celsius plus or minus 1. But they're telling us that the temperature rise is 0.8 degrees Celsius. That is within the order of accuracy. Therefore, it is absolutely and totally scientifically invalid to say that this is the hottest or coldest. We never hear about the coldest, we always hear about the hottest. And so the fundamentals of science have been abused. And it's things like measurement. How did you measure it? What was it measured with? When was it measured? Who measured it? What was the order of accuracy? Those questions don't get asked. And our Bureau of Meteorology, I think, has really dropped the ball on this one, and Jennifer has got her teeth into this one and she won't let it go.
I have it on good authority from a retired BOE meteorologist. They believe they can fix all those problems with statistics.
Mm-hmm. I'm a monkey's uncle.
They believe it.
Well, belief is a word of politics and religion. It's not a word of science.
Yeah, I know. It's incredible.
Brian, on previous times that I've seen you speak, the subject of undersea volcanoes came up, but a bit of time's gone by, not as much as you've talked about, but there's talk, I've read newsletters talking about undersea volcanoes under the Atlantic and under the Indian Ocean that I'd never heard of before. I presume you're following this field. Would you like to comment?
Yes, there's a chap in Hong Kong, Wis Yim. I had a couple of beers with him about 6 weeks ago in Honkers, just before the rugby. I just happened to be there before the rugby. I mean, there's strange things. And he's done some really interesting work looking at some Arctic submarine volcanoes. And these had about 13% carbon dioxide dissolved in the melt. Where did that go? Dissolved in the bottom waters, which are cold, dense and saline. That's what you want for solubility. He's correlated those eruptions, which he's been able to get from seismic information, with the warming of the Arctic. We have some other wonderful correlations in the East Pacific Rise, which is where we're pulling apart the Pacific Ocean, and deep fractures are causing partial melting of the mantle and rocks come up. When those rocks come up, you pick it from the seismic information, you get a lot of micro earthquakes, and you can work out the volume of melt that's come up. That melt, we know from experiments, to make it, you've got to have about 1200 degrees Celsius. You've got to cool it to 2 degrees Celsius, so you heat water, and there's a very good correlation between seismic swarms and El Nino, which is quite fascinating. There's also some work done on the Indian Ocean. We have a few supervolcanoes on the floor of the Indian Ocean, and what happens is you put this great body of molten rock on the floor of the ocean. What happens at sea level? It goes up. So you can actually correlate submarine supervolcanoes with sea level changes, and I guess my conclusion on this is there's a hell of a lot we don't know, and it's out of sight, and we know more about the moon than we do about our ocean floors. On planet Earth, we have 1,800 known active terrestrial volcanoes. Now, a few of those, like the current Hawaiian eruption and those on the Galapagos, and these are basalt. And in basalt, we've done a lot of experiments on it. You cook up basalt and it will dissolve a huge amount of carbon dioxide. If you cook up other volcanic rocks like rhyolite and try to cook that up with carbon dioxide, it hardly dissolves any. Now, most of the terrestrial volcanoes are rhyolitic, which means that they don't emit much carbon dioxide. And so you'll see people say, oh, well, look, we've measured the amount of carbon dioxide coming out of volcanoes. They don't tell you that that particular volcanic melt composition does not dissolve carbon dioxide. Yet you go to the ocean floor where there are basalts, and there are only 3.47 million volcanoes on the floor of the oceans. And we know that on the floor of the oceans, and we get it just north of New Zealand, in the Kermadec Arc, we've got liquid sulphur on the sea floor, and bubbles of liquid carbon dioxide are coming up through it. Look it up on the web, it's just incredible. We have pools of liquid carbon dioxide on the sea floor. So the bulk of the world's carbon dioxide doesn't come from industry. It doesn't come from you breathing out. We're breathing in 0.04, it's a bit higher probably in this room because the door's closed, but we're breathing in 0.04 and breathing out 4%. The bulk of it is from ocean degassing. And down there, you dissolve carbon dioxide coming out of volcanoes into seawater. You can test it. Get some seawater and work out, just measure how much carbon dioxide dissolves in it at certain temperatures, then do it at certain pressures, and you'll find that if you've got cool, high pressure seawater, it dissolves huge amounts of carbon dioxide. That doesn't bubble to the surface. It stays dissolved in seawater. And in the areas of upwelling where you get the great fishing grounds, it comes up and we degas the ocean of carbon dioxide. It's been a process that's only been going on for thousands of millions of years. So when we look at the moon and other planets, a major gas in the atmosphere is carbon dioxide. They are the rocky planets. Rocky planet Earth did the same. We went from 20% to 0.04%. Why? Because we've got water on this planet, and we were able to naturally sequester carbon dioxide into dolomite and then into life, such as vegetation and such as shells. So there is a huge amount of information out there, but an atmospheric person or a mathematician with their models, they don't look at other information. It doesn't fit the story. And this is the coherence criterion of science. If your conclusion is not in accord with all the other validated information, you have to abandon that conclusion. That has not been done. So we are not dealing with science. We are dealing with a political movement that is actually trying to steal money from your pocket and put it somewhere else in the world into someone else's pocket. And during that process, there are a lot of sticky fingers that money goes through. Thank you.
Is there some point inducing the greenies to go on about the ocean acidification? Because that is just so easy to bust.
How can you argue with someone who's got into their position without using logic? How can you use logic to get them out of that position? It's a futile task. The word acidification is the wrong word. The oceans are alkaline. They've always been alkaline, and if they weren't, you wouldn't have fossil shells because they would have dissolved. So we can look at seawater and look at its chemistry, and it is internally buffered, and that stops it becoming acid. But what you never hear about is the other buffer, the external buffer. Seawater, especially when you pull apart the ocean, seawater circulates through the top 5 kilometres of crust. There are a huge number of chemical reactions that take place. We know them because bits of seawater have been pushed up into islands like Cyprus. You've got a lot of this stuff down at Gundagai and other places. You see the old sea floor. That has chemically reacted with seawater, which is extracted chemicals from seawater to keep it permanently alkaline. So if we stop moving the plates around on the Earth, you could possibly end up with acid water, but don't wait up.
So I'm just thinking in terms of drawing the lefties into entrapping themselves. I think we all know here that the ocean acidification stuff is just so fast that it's such malarkey.
You can't use logic. I've found it with the creationists. People get themselves into a certain mindset by using no logic. No amount of logic will persuade them that they've taken the wrong path. You can't use logic. With the creationists, one of the best weapons I found was to mock them and to make fun. And I think that's the same with the Greens. Just take the piss and laugh at them, because the one thing I'm serious about as being a Green is I'm really serious about stealing your money and changing the world. It's a very serious mission that I'm on, and if you take the piss, you've disarmed them.
I just think that if you ignore the buffering momentarily, I think if you dissolved all of the carbon dioxide in the atmosphere in the oceans, how much would it drop the pH by?
Less than 1 unit.
Yeah.
The simple basics I use, there's 48 times more CO2 in the oceans than in the atmosphere. So to double, and if you, for every doubling of the CO2 dissolved in the oceans, the pH drops by 0.4 stops. So even if you double the CO2 in the oceans, which requires a 48 times increase in the atmospheric concentration.
And what you will do is to precipitate calcium carbonate.
Well,
you can do it in the laboratory. So you're actually removing the carbon dioxide from the ocean. And the key to the oceans is not the carbon dioxide, it's the amount of calcium that's washing off the land in creeks and rivers and streams and ending up in the ocean. If we ran out of calcium coming into the oceans, you'd have a problem, that you would start to lower the pH of the oceans. But you've got to stop rainfall, you've got to stop weathering, you've got to stop erosion. Don't wait up.
Ian, can you comment on ocean currents and their effect on climate change?
Firstly, Peter, thank you for that lovely fluid. The Sumerian who invented it, I believe, never got a knighthood. It's a tragedy, but should have got one. Currents transfer heat. Because of the thermal capacity of water, it holds a lot more heat than the atmosphere. So ocean currents are driven by many things, driven by the shape of the sea floor, driven by volcanic action, driven by the shifting of heat, such as the Humboldt current, moving colder material to the north. They're driven by the Coriolis force, and ocean currents transfer heat. And we all know that the reason why England, with its filthy climate, is still a benign place compared with what it could be, is due to the Gulf Stream. And so ocean currents are the conveyor belt of heat. They're also the conveyor belt of nutrients, and ocean currents are bottom-hugging currents. It's a wonderful expression. But also they can be in the upper part of the ocean. And most of the heat is transferred by the currents we don't measure, and they're the ones at 5 kilometres water depth, the bottom-hugging currents. We seem to get the view that the atmosphere drives climate. The atmosphere is pathetic compared with the ocean and the ocean currents.
So their effect on climate is presumably of a shorter term nature. This is not going to affect yours of 100 million year or even 10 million year climate. Is that right?
Ocean currents have always been there, transferring heat. And we can, in the geological record, claim that this particular rock type was laid down when we had warm ocean currents proximal to the depositional area. Now we see that today. You look in, I mean, I once went for a swim at Swakopmund off Namibia, with the current going north. Bloody hell, freezing. Yet I was at the Tropic of Capricorn. These currents carry a lot of water, and as a result of that current, you have the deserts of Namibia. You look at the Humboldt current, as a result of it, you've got the deserts of Chile and Peru. Because cold water and cold climates drives aridity. It's not warm times. So yes, we can see in the present the ocean currents are controlling, but we can also see in the past the ocean currents have had a lot to do with it. For example, if we go back and look at the materials, let me think. We think of this area here. We were polar 260 million years ago, and it was very cold, and we had ice sheets because they've left the debris behind, and we had cool climate vegetation, which is now coal. A little bit further north, our currents must have been taking very cold water north, because in exactly the same rock sequences to the north, we see what are called the red beds. These are red sand dunes that are now solid rock. We see a lot of rock salt, and we see it from Yorkshire right across into Siberia. All the salt mines are in these materials where it was so cold, we evaporated seawater and we precipitated salt. So we have a good geological correlation. Tie that into measuring the ancient magnetic field, and you can work out what latitude you're at. And you can put together the climate of the planet by those sort of tricks, by looking at what the rock is, what the climate was, and looking at its ancient latitude.
And that can actually be quite localised in terms of the whole Earth.
Oh, very much so. It also, as it is now, and it also can be latitude driven, as it is now.
And don't forget that you get multi-decadal changes in how those currents transport heat.
Oh yeah, you've only got to sneeze and they move.
They're oscillations that go from some of the century scale oscillations
Yeah.
right down to years, so dozens of them.
A question from the back from Paul.
When you mentioned how thick the ice got at the equator, it started me thinking, is there still the same amount of water between the oceans and the atmosphere now as then, or is some of it sort of tied up in rocks and limestone? I mean, I don't know what's in
No,
it.
that's a really good question. I'll take a few steps back. Where did the water for planet Earth come from? One school of thought says it may well be from comets. Comets have a chemical signature, and that idea doesn't have much support. The other is that when you look at a volcano, the major gas coming out of a volcano is water vapour. The second major gas is carbon dioxide. We've had thousands of millions of years of degassing this planet, the same as we degassed the moon, degassed Mars, degassed all the rocky planets. So we think this is primordial water that's been degassed and accumulated into the oceans. So then you say, well, why haven't the oceans got bigger and bigger and bigger? Because they haven't. Because we know that from the distribution of ancient sedimentary rocks and sediments. The answer is that when you have an ocean floor, you have basalt on the floor, and above that are ocean sediments. And as continents collide, you push that bit of ocean floor beneath the continent. It's exactly what's happening in the Andes. And you bring that water back into the mantle. So you actually recycle this water in the mantle. The second thing is that there are minerals which have no water in them, and over time they chemically react and end up bonding water tightly in that mineral, and you don't release it. So there are many good examples of that. Mica minerals have a lot of water in them. Mica forms at very high pressure, but you still don't boil off the water. It's locked in there and chemically bonded. So we have cycles on all scales. We recycle rocks, we recycle water. So for example, if we give the Pacific Ocean example, we're pulling apart the Pacific Ocean and forming in there new volcanic rocks. And these fingers are representing something profound. Folks who worked in the Navy in the Second World War were towing magnetometers behind ships to try to find an iron submarine and depth charge it. And they found that we had stripes across the ocean floor. And these stripes were material that was magnetised one way, and then the Earth's magnetic field flipped, and the magnetic field was like that, and it flipped back again, flipped back again. The last time it happened was 300,000 years ago. And if it happened now, it'd be terrific. You'd have no television, no radio, no mobile phones, no nothing. It'd be great.
What would happen when the magnetic field switched?
We'd probably talk to each other because we'd have no phones, no radio, no television. We've had a hint of this. I'll come back to it. I'm getting sidetracked. We've had a hint of this when we had a solar flare in about 1986 and it bombed the whole Quebec power system. So we would destroy AC power. We would probably have a period of time when there was very little food around. It would be quite catastrophic. We'd certainly have no communications. So we can see that as you're pulling apart the ocean floor, this is normally magnetised, they're reverse magnetised, that's normally magnetised, that's reverse magnetised. And we're pulling apart the ocean floor. We can measure the age of these rocks. The ocean floor is now older than 200 million years. And we're pushing the ocean underneath South America, and say pushing it underneath New Zealand and underneath Japan. And so we push these water-rich ocean floor sediments and the basalt beneath South America, and we can test that. We get a bit of basalt and we cook it up in the laboratory at high temperature and pressure with a bit of water, and bingo, we form a rock called andesite, named after the Andes. So we're pushing this underneath South America. We lose a lot of that water, but it also participates in partially melting the basalt, comes up as the volcanoes. Every time we push it, we get a little bit of an earthquake. We had one in Ecuador 2 days ago, only 5.4, but it was 20 kilometres from where our camp is. You feel these things. You've got 34 volcanoes right around Quito. They're all andesites, they're all explosive. Why are they explosive? Because they've got a little bit of water. And as a water-rich melt comes up, all of a sudden the rock pressure is such that it just goes bang. So we have constant recycling.
Can you give an estimate? How much water is there in the mantle compared to the oceans?
Mantle, it's orders of magnitude higher, far, far higher. Yeah. So, and the mantle still leaks water. You've only got to go to a rift area. You only got to go to a volcano. That water, and you can measure from its chemical fingerprint, the isotopes, you can measure whether it's mantle water or surface water that's just been heated up and blasted out. So what our creationists want is a static planet with nothing changing over time. This is exactly what the warmists want. They want a planet that's static, and that any change must be due to you sinners. It's a religious movement.
Very pagan, very pagan.
And just to go to the question of the models, like the APCC is using, I think Karl Popper would regard them as what he'd call instrumentalism. You set up a model like this and it defends your position because it's not actually going to test any hypothesis. So they just adjust the parameters the way that Paltridge, I think, was saying in his book. So how do we go about discrediting that point of view so the focus can actually come back on scientific evidence, actual measurements?
Well, firstly, a model is a model. It's not evidence. Secondly, it is a very virtuous attempt to try to understand complex, dynamic, multi-component systems. if he reduces to one variable, which has been done, carbon dioxide, they don't work. Now, we have nearly 30 years of models, 113 of them, that just don't work. And that's the strongest way you can say, well, look, this is what people have said, this is what's happened, they don't work. But, you know,
How do you get people to see that they're not working? Is it political?
Oh, I mean, I think you're using logic, and again, you can't use logic when you're dealing with a religious movement.
So we actually need a burst of cold weather, really.
I think we've got to have people starve, we've got to freeze, got to lose jobs. I don't want that to happen, but I think that's what's got to have to happen.
Learn that lesson.
Yes, and but we're just so wealthy in this country. We can afford to waste bucket loads of money, and we do. We are so wealthy, and you know, here we are as a wealthy society. We've seen it before, the Dutch tulip mania of the late 1600s, the South Sea bubble, when was that, 1720? These were wealthy societies that just blew all this money. And we're doing exactly the same. And it will be exacerbated because we have another four-letter word, it's debt. A lot of it's hidden.
Sorry.
I just have to ask you your views and commentary on the JCU Peter Ridd situation. Being a esteemed academic professor yourself, how do you regard your colleague Peter Ridd?
Well, Philip, I've been banned from talking at JCU. That happened about 4 years ago. Been banned from talking at La Trobe University. That also happened about 4 or 5 years ago. Universities, if I look at the Newman model of a university, they're places for vibrant thought, a vibrant discussion, criticism, analysis, and they're meant to be the hotbeds of discussion. And what the JCU has done is following on from what they did to me, to stop me talking there, what they did to Bob Carter, Peter Ridd, who I know well. Peter is asking a perfectly valid question as a scientist. This evidence is a little bit weak. I'm not so sure that the conclusions are valid. Now, JCU will fight this to the end. And I've had a lot of private discussions with Peter in this because I've been quite litigious in my life also. They will fight it to the end because it's APM, other people's money. And they have everything to lose. If they don't win it, they lose. If they win it, they lose. But they are going to be so stupid that they're going to take it to the end because it is an affront to their power. You are a servant of the university. You will bloody well do what we say. Now, that's not the spirit of a university. I think Peter has been a bit naive. I support him, both financially and morally, and talk to him privately on it. Litigation is an appalling process to be in. You get milked alive, you get slaughtered, it's emotionally taxing, and I wish him well. Now, this has been the situation we've seen in this country before when Bjorn Lomborg, who is a warmist, wanted to open a centre at Flinders University or Western Australian University. Out. This is part of the breakdown of Western civilization, and this is going back to what we had before the Reformation. And I think it was an appalling situation, but I fear for Peter's health and his pocket and his marriage. So, I mean, I support him. I think we all should. But it's a no win for Peter. It's also a no win for the university. The lawyers are going to win a lot.
Always do.
Yes. Yeah.
For those that don't know, there is already. It's closed off.
No, the first one was closed off. He's doing another one now for his case. And I think this is why I used the word naive. If he thinks litigation is going to cost him $160,000, He's got to be bloody joking. This is probably going to cost 800,000. Well, I've been there. I've done it.
And the second one is closed off.
Is it?
Yeah, Peter put up a note saying, I've closed it off because that's the amount we calculated. He's done 100,000, he's done 160. You've still got people writing, when you start again, I'm standing by to put more money.
There'll be a third one, there'll be a fourth one. Once lawyers see that you can raise bucket loads of money quickly, they rub their hands. What I think will be very interesting is the discovery process. That is always the best part of litigation. And I just hope Peter has got the inner strength, especially the emotional strength, and he gets support from his wife, who last time I spoke to her, she was very supportive. But I hope he can go through with it. I think universities like that are threatening a great source of income, and that is benefactors. And I've seen letters from benefactors already that have said, well, look, get lost. So I think it's a reputational thing. He was, what the university should have done was to pull him aside and say, well, mate, you've got these serious concerns. What are they and what can we do about it? But when you're dealing with little people in power, you've got yourself a problem. It was a great university, and I've used the past tense deliberately.
Ian, thanks again for joining us. As you can detect, there's a lively group here at Five Dock, interested in science, and certainly interested in the climate debate. We meet most Thursday evenings. You're a very welcome guest any Thursday when you happen to be in Sydney, as indeed